Okay, hi and welcome to my presentation of the Wumpus World Part 2 and the complete project. So I thought I would start with a short presentation of the program, run it and show how it looks, and then we'll talk about the code. Uh, I'll show some code and talk about it. It's quite a lot, so I will try to do it well as fast and good as I can. But I can start the program or the game. Ta-da! Okay, so here we have a menu where we can choose to either play, well, a human player, the user can play the game uh, manually, or we can choose to have an AI player. So we will choose the AI player, and then we can also choose to have the AI roam free, or we can master it, and then we will it will wait for us to press a button before it does the next move. So we will do that. And here we have map now. This is the map so far as what the minion knows. And the only thing the minion knows right now is that it's over here. And it has no clue about the rest of the world. So it's facing right. Well, it has 0 points and it senses nothing. So it's considering to move right. And we can do that. So now we have marked that one as visited, and the minion is here. Still cannot sense anything, so we just keep on moving to the right. Still nothing. Now here the minion senses a breeze, and so it knows that it has to be a pit somewhere, but it can't be in the wall, and it cannot be where the minion was before because that's a safe place. So it has to be down here. So the minion then decides to move back to the left. So it goes left because that's a safe location. And from here it can go down because it cannot sense anything. So it has to be safe to go down. So it does that. And it found the gold quite fast. So we can have another run. Just speed up the process. Now here the minion can sense a stench, so it knows the Wumpus has to be somewhere here in the vicinity. So it backs off to here and it goes down. And it found the gold once again quite fast. We'll give it a third try and then we'll talk about the code. So we start there. Now we can sense a breeze. Okay, so we know that somewhere here it has to be a pit. So it backs off and decides to go down instead. And of course it can feel a breeze there too. And this is quite an awkward situation because now it can be a pit here, here, and here. So and we do not know. The highest probability for a pit is over here, but still doesn't know. So it backs off, uh, thinks for a moment, and then decides to go to this one, to this location. But it could equally well go to this location. It doesn't matter because the probability for a pit is the same. So it's just up to chance this time. So we can try and see what happens. We got lucky this time. No pit. And this could even also be not be a pit. It could just be this one. We don't know. But this is safe, so we go to the right. We feel a stench, so and we know the Wumpus can be here or here or here, but it cannot be in the wall and it cannot be where we were before because that's safe. So it has to be down here. And our minion, being safe, decides to shoot the Wumpus as fast as it can. So it decides to look down. So now facing the Wumpus, it then decides to shoot the Wumpus. So it shoots, and it gets the Wumpus. Oh yeah. So now it can go down, step over the corpse like nothing has happened, and this is a safe one, so we can continue down. Here we have a breeze once again, so we back off and then go to the left because we know this is a safe location. Here we have a breeze once again, and now we do not know because this could be a pit, this could be a pit, and this could also be a pit. So it's once again up to chance which way to go. So our minion backs off, uh, thinks for a while, and then decides to go to this one location because it figures that the chance or probability for a pit in this location is the lowest. So it goes there, and we'll see. Yep, was no pit there, but still once again a breeze. So now we do not know. This could be a pit and this could be a pit. We have no idea. So it backs off, considers for a moment, and then decides to go to this one. And we'll see. Probably there's a pit there just to show us, but we'll see. Yep, fell down a pit. Oh well, cannot win every time. So that was a bit of the game. But so we can talk about the code now, and it's quite a lot. But we import the libraries required. We create the world, and this is uh, almost all the same as the first part in the Wumpus world, where we have cells for each location in the world, and the cells can have um, different characteristics. Or in this case, it's variables or lists. And we override the string function just to be able to print out different things in the world. And then we create the world, just a 2D array with which we populate with cells. And we can reset the world, and we put things in the world, pits, wumpuses, and or a wumpus and gold. And then we just do a breadth first search to see if the pit is or if the world is solvable. If it isn't solvable, which we'll see later in the program, then we generate a new world. And then we have an echo in the world if the Wumpus is shot and screams. So here we have our minion, and that's the biggest class of them all. We have the constructor, and we have a reset minion function, which resets the minion when the game starts and the new minion is created. And we have a start direction in which the minion is facing. And then the minion can have all sorts of characteristics. It can be an AI, then alive, it can have the gold, it has its points, one arrow and a route. It makes the map when it is reset. It can have a target. A lot of things. We have a policy which we can reset. And this policy is populated by ones. I have a normalized policy if that is to be needed, but I took away the normalization of the policy and found it to when I tested did a lot of testing, it worked better for me if I ditched the normalization and kept the policy with starting with ones instead. That worked for me, and then I can subtract the possibility for different things, and then in that way manipulate the will of the minion. We make a map in the mind of the minion, which in the beginning is empty. It only has itself in the map, but otherwise it's empty because it doesn't know anything. And we have an update map function, which updates the map in the minion's mind. every time something happens. Every time the minion makes a move, it updates its map with probabilities of maybe a Wumpus in a specific location, or the probability of pits in different locations. So each time it explores and discovers something new, it can update its map with the world as the minion knows it. And then see what we will talk about. When it comes to a specific location, it can checks if that is safe, and we use the senses to investigate neighboring cells when we come to a cell. For example, when we update the map to see if what's going on in the neighboring cells. If we cannot see, or if the minion cannot sense any stench or breeze, well, then it knows the neighboring cells cannot be a Wumpus, it cannot be a pit, so it sets those to false. It's false from the beginning too, but just to make double that it's really false, it set them to false. It sets the probability for that specific location for a Wumpus to 0 and a pit to 0. And it updates its policy to to increase the will to go to that location. We let's see. If it has not, yeah, if it's going somewhere, it can reroute where it want to go, and then if it's passing already visited cell, it doesn't have to update that one because it has already been there and explored that one, so it doesn't have to update anything. So if it's just passing through on the way on the route to another location far away, it just goes through this location and doesn't update everything around it on the way. But if it's not visited, if it's a new cell, it then goes into the cell and or location, and it then looks for it looks at the neighbors for that cell. So, and here I have a function where it's about to update the probabilities, but it has to look around itself to see how to update the probabilities. Therefore, it has 4 directions in the beginning to look in, but if one of the directions, for example, is a wall, or if it's visited, or if it's considered safe, then it doesn't have to account for that location when dealing out the probabilities for the cells if it can sense anything. So then we count down, and in this case x represents the directions for which to be accounted when counting out the probabilities. And here it is. If x is 0, then it has already looked at all the other cells and doesn't have anything to add. But if we have some direction for which we haven't been, or we do not know anything of it, then we have a direction to update, so to say, or a location, a neighboring location in that direction. So then we go in and look in the directions, and if it's the neighboring cell in that direction, if it's not a wall, or if it's not visited or so, then if the minion feels a stench, then it knows, well, a Wumpus has to be close by, but it cannot be in the wall. It cannot be where I have been already, because that's safe, and I didn't get eaten by the Wumpus, so it cannot be there. So, and that is what we did up here. We counted away those directions. So if it has two directions left to put the probabilities in, well, then the whole probability is 100%. But then we maybe had two directions to put that in, which was unexplored, or which is unexplored. So then we put 50. Well, if we have a stench, then the probability for Wumpus is 50 in one direction and 50 in the other direction in that neighboring location. Otherwise, we didn't know how high the probability will be. We couldn't know that. So that's why I counted away the directions which were not interesting. Same for a breeze. If it feels a breeze, it also puts that probability out. And where it also manipulates the policy to be less adequate to go in that direction when it chooses. And if the I just said if the policy gets lower than zero, then it's zero. And if it's not safe to go there, it's not empty. And then I have, well, if the Wumpus gets a probability of 75 or higher, then there has to be a Wumpus there, because there is only one Wumpus. So it has to be a Wumpus there, and then it sets the probability to 100. And it cannot be a pit in that case, but the Wumpus is true. And it updates a couple of more things. And then it goes through the map, just if there was a small probability somewhere else in the map for a Wumpus, then it just sets that to zero, because it knows the Wumpus has to be here. So it sets every other probability of a Wumpus to zero anywhere in its own mind map. And see if it finds a pit. The pits are a little worse because there are 3 pits, and it's really hard to. Sometimes it's just pure chance. You do not know. But it tries anyway. If it finds a high probability for a pit, then it has to be a pit, so it sets it to true. And then it updates its policy and updates the map for pits as well. Then we have and then I update the whole map for the minion, because I have manipulated probabilities in the map, so we also update the entire map in the mind of the minion, just so trying to keep the map, the minion's map, up to date. And then we have the get action, where the minion decides for an action. We'll see if I get all this right, because it's a lot. But the minion have a couple of different actions it can do. It can move up, right, down, left, but it can also look up, right, down, left. And it has a Wumpus direction if it knows the Wumpus, and the Wumpus is in a specific direction from the minion. So here it investigates if the Wumpus is found, and if it hasn't killed the Wumpus, but if the Wumpus is found, then it looks if the Wumpus is on the same X or Y grid as the minion, then it wants to shoot the Wumpus. It decides fast. So, and it then has to find the right direction of the Wumpus. So it decides to look in that direction. And if it is looking in the same direction direction as the Wumpus, then it decides to shoot the Wumpus. So quite easy that. And this is just if it has decided to shoot the Wumpus, it skips all the rest of the code because the minion will not make a move other than shooting. So then it skips all this. But if it doesn't want to shoot the Wumpus, the minion wants to move instead, then it goes down to the rest of the code. And it then just updates its unvisited list. It saves an unvisited list for interesting locations to have for later use. But if it just looks in that the unvisited list to see if it has been to any of the locations in that list, and then it pops those locations off the list just to keep away doublets from that one. And it also looks here if the minion is on a route for a specific destination. The minion can set a route to a specific location, and then it's just passing through. So if it's on a route, it goes past this. But if it's not on a route, it is on a fresh location now, wants to make a new move, it goes into this part. And then it looks into its route to see if the route has exceeded 4 in length. It looks into the route. And then it looks if a safe movement is possible from the current location. So it looks in all directions to see if it can make a movement to a safe location, if a neighboring cell is safe to move to. If it cannot find any safe neighbors, then it goes into its route and looks if it has been to some locations multiple times. If it has been to some of the locations multiple times, then it decreases the will to go to that location, and so it doesn't jump to the same location back and forth. For each time it decreases the will to go there. And it also looks in the unvisited list if it has any unvisited parts. If it has any unvisited locations, then it wants to make a new route to one of those. And also it looks in that if it can find a safe route in that list. And if it decides to make a new route, it then sets the self.new route to true, and then it skips this code down to here. But if the minion doesn't need a new route, if it found a safe route from where it is at the moment, then it goes into this part, and then it looks in all directions. If it's not the wall, then it adds that direction to its action, and then it iterates through the directions. But for the next direction, which is if it has added a direction already, it goes into this part, and it looks for the policy. If the policy for the new direction is better than the old one, it then looks if the old actions policy is greater than zero, and if it's not a wall, just to make sure. Then it adds the old direction or the old action to its consider list, and then the new direction becomes the action. But if the new one isn't better from the policy, then it looks if the new one still has a better than zero or higher than zero in the policy. If the minion still is wants to go to that location, and once again, just to make sure it's not a wall, and then it looks just to see if that it's not a great risk for a Wumpus or a pet. Then it appends that one to its consider list, so it's saving that for consideration. It then goes on to the consider list to make sure it didn't miss anything. So it then goes into the list and goes through the list to see if some location in the consider list still could be better than the current action, so to say. Yeah, and then we're still in the minion's action decision. But now, if we want to make a new, if the minion decides to go for a new route, or if it's just passing by on a new route, it goes down to this part in the decision making. And if it's on a new route, it's finding a new path. Otherwise, it's on the way to the new path or new location. And if it's in need of a new route, if it's not on the way to a new on the route to a new route, or yeah, if it's not on the way to a new location on a route, but it's making a new route, it stops by here. And once again, it investigates if there's a safe location in the unvisited list where it saved unvisited locations. So it looks there if it can find a safe location, and then it appends that to its safe route list. And if the safe route is if it contains some location, then it sets the target y and target x to that location's target y and target x, and then it counts out the Euclidean distance to that to the target from the current position. And if there's several safe locations available, then it chooses the one with the best Euclidean, the closest one. And then if there is no safe locations available, then the minion will choose the closest unvisited location. So it goes in here, sets the target as just the first in the unvisited, counts out the distance, and then loops through the unvisited list, takes out the new Euclidean for the next index in the unvisited list, compares the distances, and if the new one is better than the old one, then it sets the old one as the Euclidean distance and sets the new target y and target x to the new y and x from the new index of the unvisited, and then it sets to clean the unvisited list. And when it has found the closest one in the list or the best one, it pops that one from the unvisited list, so it doesn't try to go there more. Prints out the targets and then sets the action. This I think is a rest, which I forgot to take away. Oh well. Now it looks if the target is a neighboring cell. If it's a neighboring cell, then it has found it and sets the action to go to that in that direction to as action, and then it breaks out of the loop. But if it wasn't a neighboring cell, if it didn't find it, then it has to find a safe route to that cell. So we set up a couple of variables, steps. We have search and we have a front, and then we do a breadth first search from the current location to the target location, just to find a route there and find a safe route there. So we do the search, and when we have found the location in a safe way, then we break out of the loop and we backtrack from the target. We backtrack to the current location, and when we come to the current location, we know in which direction we are supposed to move to get to that location. So we set that direction as the action then. And when we have done that, we can break out of this loop, and yeah, it just resets the steps in the minions map, because we set steps in each location to be able to backtrack. So we reset them, and then if we found it, we jump out and return that movement. We have two returns here. One which return the movement if we are about to make a move. The other return is if the minion do not want to make a move, if it instead decides to change direction and turn into the direction of the Wumpus, or if it shoots the Wumpus. Here we have the move minion function, and here we have the different actions. If we are to look in a specific direction, if we are to move in a specific direction, and it counts away the points if we move, we set the current position in the map that minion falls, and it is to be empty. And then we move, we look at the percepts, or we go to the percepts, which is down here. Then the program looks if there's a breeze or stench, then the cell or location from where we moved is not empty. And it sets the new position of the minion, and sets that to minion true and empty false. It updates the map, and it appends this position to the minion's route. And we also have the percept, which is kind of short. It just looks in the current cell or current location if there is anything to perceive there. Well, if there's a scream, and there will be a scream in the entire cave or world if the Wumpus is shot, and it will echo for a couple of rounds before it disappears. There can be a stench, and it sets the minions' percepts to true if it's stench, or if it's scream, or if it's a breeze. And then it can be a Wumpus too, and then alive is no more. And the minion gets minus 1,000 points. But it can encounter it, but it can also find the gold and get 1,000 points. Be very happy. Then we have the possibility to shoot an arrow, which sets back the minion 10 points and takes the only arrow. We have a direction, and what it does, it looks for the minion's direction, in which direction the minion is facing, and then it shoots the arrow and basically just iterates while hit is false with this part of the code. And it just looks if this part of the cave Wumpus is true, then the Wumpus is something is hit. The Wumpus is true, that it was the Wumpus that was hit. The minion gets a Wumpus kill, true, and then the program updates the world and the minions map and looks if there was other breeze or something in the location of the minion. But it just iterates over the code, so to say, and walks through the maze with the arrow until it hits something. And direction in this case is 1, so it will add 1, and y is also this part 0, but depending on the direction it changes y and x, so the arrow can fly through the maze in the direction the minion is watching. So here we have a minion, but and now we've come down to the main part of the program. Nothing too fancy in this one. We welcome the user, print it out in a fancy way. We draw the minion. Then we make a scary world. We put things to the world. We look at it's solvable and such. And then we run the program in a loop until the user chooses to exit the program. And then we have an input control which loops this part of the code if the user makes a bad input, writes something wrong, or chooses an action that isn't possible to choose. So we have the menu which prints out a couple of actions and then asks the user to choose one of the options. And it is in a try, which it can catch down here in the exception if the user makes something bad. So it catches that one in that case, and it can catch here too for the follow-up question if the user chooses to let the AI play the game. But it then just starts over and let the user try once more to choose amongst the options. Then we reset the world minion, so solvable if false, and then we do the reset world and put things, and then we look if the world is solvable. So if solvable is false, then it will make a new world until solvable is true and the world is solvable. Then a minion gets created and the minion's policy gets reset, and the minion adds its current location to the route, its own route. And if AI is chosen up in the menu, then minion.ai gets true, and minion, uh, the minion's percepts gets updated, and the minion's map gets updated too. And then we play the game as long as the user wants to play the game. So we iterate in the game as long as the minion is alive, or the gold is false, or and the user wants to play the game. And then we have just the echo, which if there is an echo in the world, it starts to count. And after a couple of rounds, the echo silences. Then we print out the world. I have taken that away, but it's the code over here that prints the world with all elements visible. So in the testing, I could see the real world, so to say, and here we have the minion's world, or the map of the minion, as much as the minion knows at the current state. So I could compare the two to see the entire world and compare it to the minion's knowledge of the world. And then we print out some facts from the minion, the facing direction, the points, if the minion senses anything, nothing. And then we get if not AI, if a human is playing, or if the user is playing, then we print out. Let's see here, I have printed double. Oh yeah. Well, we print out the policy of the minion, and then we print out the possible actions and let the user enter an action and see if the user chose an action which is possible. Otherwise, the user gets to try again. And if it's the AI that's playing the game, then the movement is chosen from the minion's get action, which was the long function which chooses an action from the minion's knowledge. So once again, we get the minion's policy. We look, print out that if it's thinking, the movement the minion is considering to do. And just print some blah blah. And then if the user decides to let the minion walk freely without the user having to press for the next action, then the minion sleeps for 3 seconds before making the next action, so still the user gets the chance to see what's happening. Else, if the user wants to control the minion, then the user has to push a button or press a button for the minion to make the next step or next action. And then the program proceeds with the chosen action if it was valid. And here we can have a shoot action or movement. And then it gets the hit from minion from the shoot arrow function of the minion. And then goes through that. If it misses, it gets a bump in the wall. And if the user tries to shoot an arrow when there is no arrows left, oh well, too bad. Then we have a movement. We can move up in a different directions. We can also look in the different directions, and we can choose to exit or reset the game. Or if the user did something bad, we have one exception that catches an exception, and one catch if they didn't get an exception. And then we look if the minion is alive when we after the round or move. If it's alive or if it ran into a wall. And if we choose to exit the game, then we print out the map. And if the minion got walled, we print something. Otherwise, the minion either died or if we exit the game, it disappeared in the maze. And the user gets asked if they want to try once again in the cave, play once more. And thanks for playing and bye bye. So I think that was everything. It was quite some code, so hard to remember everything when you're talking about it, and it's easy to get lost in the code. But I still think the game performs quite well. It's not 100%, and it sometimes makes a bad decision, or not bad decision, but when the probabilities are equal, or when it's up to chance, well, you can get unlucky and jump in a pit, or so to say. But anyway, I'm quite pleased, and it works quite okay, I think. It was really fun and interesting to do, and well, I there can be, of course, much improvement to this one, but for this time period, I'm happy with it. So I think that's all for me, and hope it's fun to try and play this. Uh, have a good time. See you. Bye.